Welcome to this video where we'll look at how to solve problems using the suvat equations. Firstly, make sure you're familiar with what each of the letters represents. And these are the 5 equations, though as this is aimed at A-level physics, where only these 4 are generally considered, we're going to concentrate on these 4. We're now going to work through these 6 steps, one at a time, with an example problem. Our example problem is a lorry accelerates from rest to a speed of 18 meters per second in 15 seconds. Calculate the distance travelled during this time. Step 1 is to draw a diagram and include an arrow to show the direction which is going to be taken as positive. We're told that it starts from rest, which means at the beginning it's going at 0 meters per second, so we can label that on our start diagram. And then for the end, we're told it's going at 18 meters per second, so we can label that on the end diagram, and then we're going to define that way as positive. Step 2, we're going to write down all the information that we know, put a question mark for the thing we're trying to find, and a cross for the thing that we don't know and we're not asked to calculate. We now need to fill in for each of these. So we are told that we're calculating the distance, so therefore we're going to write a question mark for S. We are told, which is what I call hidden information, that it starts from rest, so the initial velocity is 0 meters per second, so we can fill that in. We're told the final speed or final velocity is 18 meters per second, so we can fill that in as 18 meters per second. And we are not told the acceleration, and we're not asked for it. So therefore, we can put a cross by the acceleration, and we're told that the time is 15.0 seconds, so we can put our time as 15.0 seconds. Now we need to select the equation which doesn't contain the quantity we don't know and we don't want to find out. We put a cross by acceleration, which is because we don't know the acceleration and we're not asked to find it out. So we need to look through the equations and find the one which doesn't contain that, which in this case is S equals a half U plus V times T. Step 4 is to substitute the values into your chosen equation. S is what we were trying to find, so we would still write S equals, and then we've got our half times U, which was 0, plus V, which was 18, multiplied by the time, which was 15.0. And now we can put all those numbers into the calculator and we'd get 135 meters. In this case, we didn't need to change the subject of the equation, so we can move to the final step of rounding the answer to a suitable number of significant figures and giving a unit. Since our data was all given to 3 significant figures, we should give our answer to 3 significant figures, which it already is, and I already wrote in the unit of meters, so we're finished. I'll finish with a few tips that will help you with other suvat questions. Always remember, if it starts from rest or goes to rest, then that means 0 meters per second. If it's reaching a maximum height, that means the final velocity will be 0. Make sure in your writing that you can tell the difference between a U and a V. Always write your U with a tail and your V without. And then even if it gets a bit messy, you can tell which was meant to be a U and which was meant to be a V. If it tells you that it's in free fall, then the acceleration is equal to 9.81 meters per second squared, or whatever your exam board requires. Often in maths, they want you to take it to be 9.8. Watch out with this to make sure that you're defining which way is positive and which way is negative, as if you have things in more than one direction, you have to be careful with that. For example, with the ball going up, but the acceleration due to gravity acting down, then the velocity and acceleration will be in the opposite direction. Remember, you can only apply these equations when the acceleration is constant. And if you have a situation where the acceleration is 0, then you can make things easier for yourself by just using that displacement equals speed times time, which is much simpler than using the suvat equations. I hope you found this video useful.